The third factor will be the distance from vibrating body. That's pretty sensible because when a person is near the vibrating source, it will hear a louder sound. But when a person is at a distance much greater than the previous one from the vibrating body, then he will hear a fainter sound, a sound of low loudness. Okay, so why does it happen? It happens because as the sound vibrates through the medium, it loses its energy. As it loses its energy, it loses its amplitude. Okay, here the distance is much greater. So while traveling from this point to this point, the sound wave have already lost pretty much of its energy. Therefore, the person standing over here um, can hear a fainter sound, a less loud sound. Okay, so these are the three factors which affect the loudness of a sound. Loudness depends on these factors. Remember that loudness enables us to distinguish from loud sound to faint sound. Next one is pitch of the sound. It depends upon the frequency. As we've seen that loudness depends upon the amplitude of the vibrating body. Similarly, pitch depends upon the frequency of a vibrating body. We've already discussed that frequency is the number of waves passing through certain area in 1 second. Here we see that this wave has a higher frequency because more number of wave passes through this area as compared to this wave. This one has a lower frequency because very few wave passes through this certain area in given amount of time. Okay, now so pitch enables us to distinguish shrill sound from grave sound. Remember that loudness of sound can be distinguished by, you can hear me, I'm saying loudness of sound and loudness of sound. This and the last one was fainter sound and the first one was loud sound. But what does pitch do? The pitch enables us to distinguish between shrill and grave sound. What is a shrill sound? The sound of a girl, of birds, or you can say the sound of like these shrill sounds are of higher frequency. Okay, these higher frequency enables us distinguish from lower frequency. So in turn, these lower frequency are called the grave sound. The sound of a drum, the sound of a gentleman, the sound of men are of lower pitch. The sound of women are of higher pitch. Okay, so the graver the sound, the lower the frequency. The drum has a lower frequency, so it has a lower pitch. The shrill the sound, it will have a higher frequency. The pitch of chirping of birds is higher than that of a drum. Okay, so pitch enables us to distinguish between shrill and grave sounds. Now, coming to the third one is the intensity of sound. Okay, here this one's gonna take a little bit much time. Intensity of sound, the energy carried by sound waves per unit area per unit time perpendicular to the direction of propagation of wave. So mathematically, here the intensity is directly proportional to energy. The more the energy, the more intense would be the sound wave. Energy equals to intensity equals to energy divided by unit area and unit time. So we mean that intensity is how energetic how an energetic wave passes through an area in unit time. Okay, we also know that energy over given time equals to power. So the intensity can also be defined as the power per unit area. Okay, we can demonstrate it using this diagram. Okay, so here from this red pen I've drawn the energy waves. Okay, these are all energy waves. So, and in the center I have placed this box. This contain 1 meter square unit area. Okay, so intensity would be how much wave passes through this unit area in unit time. How much energy passes through this unit area in unit time. So if we say that more energy passes through this area in 1 second, then intensity will be greater. But if we say less energy passes through this unit area in unit time in 1 second, then the intensity will be lower. Okay, coming to the mathematical equations. Here we know that loudness depends on intensity. Okay, coming to the mathematical points. Here, don't get confused with this log. Girls, don't get confused with it. I'll show you its purpose in this equation. So the loudness depends upon the intensity, or the intensity is dependent upon loudness. The more the loudness, the more will be the intensity. The more will be the intensity, the more will be the loudness. Okay. So removing this proportionality sign will get k. K is the constant of proportionality, nothing else. L is the loudness of the given sound, which is equal to k, which is constant, times log of the intensity of that sound. Okay, so we call this equation number 1. And we take another equation number 2, which is the L naught equals to k times log of I naught.